model actually it evolved. Okay. What all things are we going to cover first? So the concepts, formulation of the model. Okay. The solution procedures for IFS means initial feasible solution. Okay. Or it is also called as BFS, that is basic feasible solution, and optimality check, balanced and unbalanced kind of problems, maximization and minimization. There is a condition which we look at it here in case of degeneracy. That means number of solutions, number of allocations can be less than m plus n minus 1, where m stands for number of rows, n stands for number of columns. Prohibited routes, routing problems. So even those kind of things would be seen. As we have seen in case of assignment problems, there were some cells where allocation was prohibited. That means we don't want any allocation in those cells. So similar kind of situations we'll be looking at in case of transportation problems too. And once you have received an optimal solution, then if there are any changes, then what? How do you manage it? Okay, so this is the scope of what we are going to look at here. We are not looking at this multimodal transportation. Multimodal means from one point to another point, mode A, from point 2 to point 3, mode B. That means उसमें rail route plus road transport, shipping, सब कुछ include करके वैसा नहीं है. Okay, so that is not a part of syllabus for you, but transportation model actually spans and goes beyond that. Okay, and it goes up to multimodal. यहाँ पर हम जो भी देख रहे हैं will be single mode. Okay, अगर सबका सब shipping का है तो सब shipping का ही है. Shipping plus road वैसा सब options नहीं होगा. Okay. Basic feasible solution that we are looking at. Again, here also the model would be constructed in a tabular form, in a form of table, wherein on one side we will have the source from where the material or material would be moving, or the resource would be allocated to another point, that is the destination. Okay, so source, destination. जैसे हम लोगों ने traveling salesman में किया ना, you had point of origin and destination point. ठीक उसी तरह से we will have it here also. So there are multiple methods which can be used for arriving at a basic feasible solution. So some of them is called as northwest corner method, least cost method, Vogel's approximation method, and fourth is my method. My method means every individual's method, his way, his whims and fancies. Okay, so we'll see all four of them, and then we'll look at the optimality check methods. That is two methods which we talk about. One is a stepping stone method, and second is a modified distribution method, or also called as UV method or penalty cost method. So sometimes shortly referred as penalty method. Okay, so these are the things which we are going to cover in our syllabus. The methodology has been explained in the form of a chart, so you can refer to this for getting better understanding. Anyway, instead of putting in extra time there, what we'll do is we'll take up a model and we will understand the methodologies first, and then we will see how and where all we can apply these. Okay. Done. Anything that you would like me to include, anything else other than this?
No, sir.
Okay. So we will use similarly the I would say first we'll start with manual method. Okay, I'll be using a blank PPT at that time because it is easy to write on it, correct? So to explain it to you, it would be easy. So same like last topic, will be using both the methods. That means manual method as well as using Excel. So we'll start with this first. Let me just copy and paste it in Word. I'm just putting up the structure in place. So this is my table. I'm going to let me make it a blank page. Increase the font size so that it is visible to all. Is it visible to all, or should I increase more?
So it is visible.
Uh, Here on this side, it is indicated as demand, and this one is your supply capacity. Okay, you have got supplier 1, supplier 2, supplier 3, and so on. Okay, so you have got 3 suppliers in this particular example, and just put it in a PPT mode that it is visible to all. Now I will be needing a pen. Okay, this becomes my board. Something more needs to be done. I'll just, these are my cost elements. Okay, so Let me put them on the left hand corner. Now, I have got 3 suppliers and 4 demand centers. These demand centers could be, say, your warehouses. It could be your markets where you want to deliver some material. So, let's say my supply center, it can be my plant 1, plant 2, plant 3. Okay, or it can also be my warehouses. Warehouses at different locations. Now, from these locations, if I have to supply it to this demand center, okay, it will cost me say 4,000 rupees per ton of material movement. Okay, the supply capacity of this center is 40 tons. Okay, and the demand at this demand center is for 20 tons. Okay, are we clear with the background? When I'm supplying it from one supply source and delivering it to another delivery center, this is my cost. If the same material being supplied from supply source 1 and delivered to destinations 2, this is my per unit cost. Okay. Similarly, this becomes my per unit cost if I am delivering the material from supply source 1 to delivery center 4, or this becomes for 3. Fine. Are we comfortable with this?
Yes, sir.
So supply source 1 has a capacity of say 40 tons. Supply source 2 has a capacity of 60 tons. Supply source 3 has a capacity of 50 tons. Altogether, the total capacity is 60 plus 40 is 100 plus 50 is 150. Are we okay with this? Somebody please respond.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
When looking at the demand centers, D1, my requirement at demand center 1 is 20, demand center 2 30, demand center 3 50, demand center 4 50. So altogether, my total demand is also 50 plus 50, 100 plus 30, 130 plus 20 is 150. So it's a matching condition. That means demand is equals to supply. Is it okay? That means this is a balanced problem. Demand is equal to supply. In reality, you may not always have demand matching with the supply. So problem can be unbalanced also. And in that case, appropriately, a dummy row or a dummy column needs to be inserted. Okay, up to this? And do you include a
Yes,
dummy row or a dummy column?
When supply and demand are of the
yes,
same.
sir.
Not matching. Now, tell me, if demand is less than the supply, will you include a dummy row or a dummy column? When demand is less than the supply, you will include a dummy row or a dummy column.
सर नीचे और एक रो आएगा क्या एसपी के नीचे?
सर रो आएगा शायद ऐसे।
I don't know. I may be wrong, but
So I think it's called.
A dummy column, sir.
Who said column?
So Akshada.
Akshada. There was one more girl who said column. Akshada and then
Shraddha, sir.
Shraddha. Very good. We will require column. And the demand for the column, total demand for the column would be equal to the gap between the supply and demand. Okay. अगर आपका supply कम होता as compared to demand, then we would have included a row. And the total supply capacity of the dummy row would have been equal to the gap between the supply and demand. Clear?
Sir, can you repeat?
Okay.
Row and column wala what you told.
I will tell you again. If demand is less than the supply, we'll have to include a column. Okay. If demand is less than the supply, we'll include a column. The column dummy, the dummy column will have a demand equal to the gap between the supply and demand. That means total supply or total demand के बीच में जो difference आएगा, that would be the value total demand for the dummy column, that is dummy demand center. Okay. As we go along, we will see that also. But this is how the logic works. In case if the supply is less than the demand, then we will include a dummy row. Okay. And the total capacity of the dummy row would be equal to the gap between the supply and demand, or demand and supply, because इधर पर demand ज़्यादा है ना. Okay. Are we clear up to this?
Yes, sir.
Yes, sir.
The values which are indicated within the table, that is 4, 6, 5, 6, 8, 7, are per unit cost for the material movement from S1 to D1, S1 to D2, S1 to D3, and so on. Okay. Now, northwest corner rule says कि सबसे पहले northwest corner cell में जितना आप maximum allocate कर सकते हो, please go ahead and allocate. Okay. So the supply capacity of S1 is 40 and demand of D1 is 20. So we can make a complete allocation of 20 units here. Okay. The minute I supply 20 units to D1, the demand for D1 will reduce to 0. That means it will not have any more demand. But at the same time, the capacity of S1 will reduce to 20. Correct? Now supply capacity of S1 will be only 20. Are we okay with this? Is everybody able to follow?
Yes, sir.
Yes, sir.
Now, since we have made that allocation, no further allocations would be possible here. Fine. Now, which is our next northwest corner cell? This one, S1D2.
Sir,
Yes. This
So-
is my north.
sir, could you please repeat once again? Because you had mentioned that 4, 6, 8, these are the per unit cost, right?
Correct. Correct. Okay. So I will repeat after that. See, my supply source S1 had a supply capacity of 40 units. Okay. And demand center D1 had a demand of 20 units. Now, if I start with northwest corner cell rule method, it says allocate the maximum possible in the northwest corner cell. So what is the maximum possible allocation for the northwest corner cell? This is my northwest corner cell, northwest. So this is my northwest cornered cell. So if I look at what is the maximum that can be allocated here, so supply capacity is for 40 units, whereas demand is for 20 units. So S1 can give 20 units to D1. Simple, correct? The minute I make an allocation of 20 units here, okay, my capacity of supply for S1 reduces from 40 to 40 minus 20 gives me 20. Are we okay up to this? Are you able to see my pointer also?
Yes, sir.
Okay. Now, since S1 has supplied to D1 all the 20 units required by D1, so the demand for D1 has exhausted. It has become 0. So that means they don't need any material from S2 and S3 now. So what I have done is I have just crossed these cells and I'm not going to use it for further allocation. Are we okay up to this? Comfortable?
Yes, sir.
So can you repeat the sentence again, please?
The minute I have made an allocation of 20 units, okay, S1 has supplied 20 units to D1. Now D1's requirement has exhausted. That means it doesn't need any more supply from anywhere, neither from S2 nor from S3. So what we are going to do is we'll just cancel these cells, indicating that we are not going to make any allocation further in these two cells. Okay.
Okay, sir.
Okay. Now, my next northwest corner cell, since now I have already made an allocation here, these cells have got cancelled. So this entire D1 is out of question now. Now my next northwest corner cell is S1 D2. Now S1 D2 has a requirement of 30 units, whereas S1 can supply only 20 units. So what we'll do is we will allocate the maximum possible. So maximum possible allocation would be of 20 units only. Correct? So the minute S1 supplies 20 units to D2, the requirement for D2 will be left out only just for 10 more units. Correct? 30 minus 20 would be 10. And the supply capacity of S1 will reduce to 0. That means it cannot supply to anybody else now. Since it cannot supply to anybody else, that means D3 or D4, so just cancel these cells. Clear? We will ignore these cells for further allocation. Now my next northwest corner cell is S2 D2. Now, how much is the maximum that we can allocate here?
10.
10.
10.
10. Very good. अरे वो 0 की जगह पर बॉक्स बन गया, भावनाओं को समझ लेना. So this requirement changes to 0 and supply capacity of S2 will reduce by 10. So that means new supply capacity for S2 would be
50, sir.
50. Fine. Okay up to this?
Yes, sir.
Yes, sir.
Since demand for D2 has exhausted, we will not be having any allocation in this cell. Correct? Fine.
Yes, sir.
Yes, sir.
My next northwest corner cell would be this. Okay. How much can I allocate here?
50.
50.
50.
Sorry, थोड़ा सा इसमें लिखने में थोड़ी सी दिक्कत होती है, but please, I hope you will be able to make out.
Yes, sir.
Fine. So since I have allocated 50 here, the demand for D3 has exhausted and has turned out to be 0. So no further allocation possible here. At the same time, since I have allocated 50 here, so the supply capacity of S2 has also reduced to 0. So no further allocation would be possible here. Are we okay up to this?
Yes, sir.
Yes.
Yes, sir.
Now, what is the next northwest corner cell? This one. Correct? अब इसमें हम कितना allocate कर सकते हैं?
50.
50.
50, sir.
So we will allocate 50 here. The minute I have made an allocation of 50, so demand for D4 has reduced to 0 and supply capacity of S3 has reduced to 0. So I have allocated all. And now what is my total cost of allocation? Total cost of allocation will be equal to 20 into 4. 20 into 4 would be 80. 80 plus 20 into 6, 120. 80 plus 120 is 200. Correct? 200 plus 10 into 8, 80. 280 हो गया. Plus 50 into 6. So 300, 280 plus 300 is 580 plus 50 into 8, 400. So 580 plus 400 is 980. Fine. Since I said that this is equal to 4,000, 6,000 and so on, so 980,000. That means 9,80,000 would be your total cost when I am following a northwest corner rule method. In this particular case, we call it as a basic feasible solution because it is taking care of my entire demand as well as entire supply. Okay. And what is the number of allocations that we are getting? 1, 2, 3, 4, and 5. 5 allocations. How many number of rows are there? So what is the value for M? M is number of rows. How many rows do we have?
3.
Sir, 3 rows.
N number of columns.
4.
So if I have to tell you M plus N minus 1 will be equal to how much? 4 plus 3 is 7, minus 1 is
6, sir.
6.
6. So how many allocations have I got? 1, 2, 3, 4, 5. Number of allocations should be less than or equal to M plus M minus 1. It cannot be more than that. Okay. Number of allocations will always be equal to will always be less than or equal to M plus N minus 1. Normally, the number of allocations should be equal to m plus n minus 1. If it is equal to m plus n minus 1, we call it as basic feasible solution. But if it is less than m plus n minus 1, we call it as degenerate basic feasible solution. Okay. So this will talk about why basic feasible solution, whereas if it is less than wala condition, okay, so then it will be called as degenerate basic feasible solution. Fine up to this?